To find the UDL for this particular beam, it's simply supported at ends of a span 9 meters. So we could draw that out. So it's a 9 meter simply supported beam. We have a UDL on the top that we're trying to find out the safe value. So it says find this UDL value, and it's got the permissible bending stress is 165. So in terms of finding out the UDL, we could look at the strength of the material. So we could find UDL based upon your stress value, or the internal stress value of the beam, which is 165. And we'll compare that to the deflection for this beam also. So we're looking at the ultimate and the serviceability to try and find out the value of the UDL. We are given the deflection must not exceed 1/360 span. So our deflection is span over 360, or 9,000 over 360, and put it into millimeters. So if we looked at our deflection, the serviceability side first. So again, looking in your handout, looking for a simply supported beam with a UDL, our deflection, maximum deflection, so you'd have to get this from the table, is 384 times by WL cubed over EI. So that's from the table. So we're looking at the serviceability first. I.e. the deflection delta. We're told that this deflection, the maximum is the span over 360. So if we put these values in, we got the 5/384 times by W times by the 9,000 cubed over. Now we're given what E is, so it's 205 times 10 to the 3 kilonewtons millimeter squared. So should we, like, this is where we need to be thinking, okay, so how are we going to look at the units for this? We've got the 9,000, so that's in millimeters. Our A value is in kilonewtons per millimeter squared. We've got kilonewtons up here, so this means our W is going to be in kilonewtons when we end up getting this value out. The I value, we have to get that from the table. So if you looked up a 356 times by 171 times by 67 beam, in your tables, you should find your I value is 19,460 centimetres to the 4. But we're putting everything into millimetres, so it's 19460 times 10 to the 4 millimetres to the 4. So put that value into here. If we rearrange, that there equals the span over 360, which is 9,000 over 360. You can either multiply that out or rearrange it and work out what W is. W is 105,067 newtons. Or 105. So that's found the total load for the deflection. We next have to look at the total load for our stress of 165. This is where, if you look back, when we looked at its stress, you have formulas, and these are in the these are in your handout. So you got your internal moment is stress times by the Z value, and if you look in your tables at what the maximum moment is for a UDL simply supported, it's WL over 8. So if we make both of these equal each other, and we can rearrange that, so we've got W equals 8 times by stress times by Z over L. We've got this stress value, 165, we've got the span, we haven't got Z. From your table, we can find Z. Again, for this beam, which is a 356 times 171 times 67. Now, when you look at the tables, you can get a ZXX and a ZYY. So in terms of this beam, it's been loaded along the top. We want the XX value for this beam. So from the section tables, your ZXX is 1071 centimeters cubed. Remember that you've got universal beams and universal columns, so you've got to make sure that you're looking at the right table. Three, five, six. So if I have a look at this table, so I'm looking at my universal beam. This is from like the British Standard 4. So I'm trying to find this beam. So I've got 356 by 171 by 67. Then I'm going along until I find my Z values. These are my Z values. The Z is the elastic modulus. And you're given these in terms of XX. And if you forget what XX and YY is, you know, a beam would be loaded upon the top. So the UDL would be applied to the top of the beam. So we want the ZXX. Unfortunately, the table gives us ZXX is in centimetres cubed, so we have to put it into millimetres by times in that value by times 10 to the 3. So that's where you would get that value from. And looking at these simply supported beams, for a UDL, for a simply supported beam, our maximum moment is WL over 8. So that's where we've got our M is WL over 8, and that's where we got our Z value from. So putting all of these values into our rearranged formula, which is 8 times by 165, and again we'll do this in newtons and millimeters. So 8 times 165 newtons per millimeter squared times by my Z, divided by my L, which was 9 meters. That gives me a W of 157.08 kilonewtons. I compare this value. So I've looked at the W for the deflection at the top, and I've looked at the W for the stress. When it reaches 105, it will fail in deflection. So therefore my safe load is 105 kilonewtons, which is based upon deflection.